Today is a day where we connect physics with the amazing invention of the toilet paper roll. Here we have two toilet paper rolls with the same mass. Both will be dropped at the same time and at the same distance from the ground. However, there is a slight twist. One roll will be simply dropped, while the other is unrolled as it drops. Which one do you believe will drop first? Well, let's find out. Without a doubt, it is the one that is simply falling in complete free fall. Using our intuition, we can imagine that the time it takes to unroll is slower than one that is not experiencing any upward force. Now, let's take this a little bit further. If these rolls will hit the floor at the same time, when will they? Well, the most logical solution would be to move the roll that is simply dropped a little bit higher. But by how much? What is the ratio of heights that the two rolls of toilet paper must be dropped from so that they hit the floor at the exact time? And this is what we're here to figure out.
Before we find the ratio of heights, we must first draw the free body diagram of the unrolling toilet paper that shows both you and I see the forces that are applied to it. Now we say the force tension is equal to mg minus ma. After using some common sense, we know the ratio of height is height 1 over height 2. Remember, height 1 is the toilet paper is dropped normally and height 2 is the one rolling down. Use a Kmax formula, ratio of height is 1 over 2 gt squared over 1 over 2 at squared. After summarizing these equations, we get g over a. We don't know what a is yet. From there, we will start a torque equation. We say that torque is equal to force of tension times the radius 2. Also, torque is equal to moment of inertia multiplied by alpha. With this, we can sub these equations together to get a new equation. As we don't know what alpha is yet, we can sub in acceleration over radius 2, and from there, bring radius 2 to the other side to get a very important equation. Now is where the derivation becomes too messy. We can substitute force tension into a new equation we came up with to get IA equals mg minus ma times r squared. Then we expand the terms in bracket and bring mr squared a over to the left side and factor out the a. Then we can rearrange the equation and isolate for a. Next, we sub in I, which is the moment of inertia of a disk with a hole in the middle, to get a more complex equation. However, we cancel out the masses, which means mass has no effect on acceleration. Then we bring over g to the other side, and the equation sort of looks more familiar. Finally, we should clean this messy equation up. This equation is a over g equals 2r2 squared over r1 squared plus r2 squared plus 2r2 squared. Then collect like terms and take the reciprocal to get g over a is equal to r1 squared plus 3r2 squared over 2r2 squared. Remember that g over a is equal to the ratio of heights. That means this equation is the ratio of heights.
We now know the ratio of heights, which means that we can make them hit the floor at the exact same time. Remember that g over a is equal to the ratio of heights. That means that this equation is also equivalent. As we know the equation, we can substitute the values for r1 and r2. From using this and the height from the ground to where the unrolling roll will be dropped, we can determine where the other toilet paper roll must be dropped from. 3, 2, 1. It is important to realize that there are some areas of error in our final results. For instance, when the toilet paper is rolling down, the radius shrinks bit by bit. So dropping from higher heights will cause the ratio of heights to be different because the radius is shrinking when it travels more distance. The toilet paper roll also may not have been at the right measurement that was calculated, or it may not have been dropped at the same time due to a slow reaction time. We now know the ratio of heights, and this allowed us to determine how high one roll must be in order for them to both hit the floor simultaneously, allowing the correlation of physics and toilet paper rolls possible. Thank you.